So our topic is dipole moment. Dipole. Before that we have discussed about the bone characteristics. So now we're having dipole moment. What is basically dipole moment? It measures the net polarity of a molecule. It measures the net polarity of a molecule. It is denoted by mu. This is a sign of mu. After that, its formula is mu is equals to q into d. What is q? Q is a charge and d is a distance. Here, this is a vector quantity. This is a vector quantity because it's having direction also. It always moves from positive to the negative. It always moves from the positive, which means it moves from the lower electronegativity to the higher electronegativity, right? So here first of all I will tell you about the polar molecule and non-polar molecule. Polar and non-polar. What is polar? Like for example, we are having H and hydrogen and fluorine, right? So hydrogen and fluorine, you can see these both are different molecules, and hydrogen is a less electronegative and fluorine is a high electronegative. So that which is less electronegative, there will be always partial positive charge, and that have high electronegativity, that will be always partial negative charge because the electron will be more towards the fluorine, so that will be having negative partial charges. Now if we talk about the non-polar, for example, we are having hydrogen and hydrogen H2, right? These both are equal, these both are the same, these both are the homoatomic molecules, so there will be no partial charge because these both are having same force of attraction, no partial charge. Now let's take the example that this is a ball, right? And here, from here, one person is we can see taking force of 5 Newton, and from here also 5 Newton force. So there will be both same forces, so there will be the net force will be the 0. Net force will equals to the 0, and the net dipole will be also the 0. So this will be called as a non-polar. We can say a molecule that having net force 0 and dipole is also 0, that will be called as a non-polar. If we take here example, like this is also ball, one person is making force of the 10 Newton and another person making force of the 5 Newton. So the force, or we can say the ball will be more towards the 10 Newton, pole will be more towards here, so there will be net force will not equal to 0. Net force is not equal to 0. Dipole will be not equal to 0 because here these both forces are the same, so the ball will be in center, not, or we can say same towards here and same towards here, but here this ball will be more towards this one side because of there is a more force between them, so the net force will be not equal to here, net force will be equal to 0. After that we will talk about, like we are having this again diatomic molecules. We are having diatomic molecules. In diatomic molecules we are having two types. Number one is heteromolecule and another is homomolecule. Heteromolecule. What is mean by having homomolecule? That having same atoms that having same atoms, like here one important point that same atoms exert same force. Same atoms exert same force. For example, we are having chlorine, Cl2, and here also chlorine, right? So there these will be, here will be the net force will be equal to 0. Why? Because these both are the same molecules. These are the homoatomic molecules. Same electrons will be here, same electrons will be shared here. So these both, here the net force will be equal to 0 and dipole will be also equal to 0. So this will be called as a non-polar. Now here if we talk about the O2, this is the O2, right? Here net force will be also 0 because these both are the same molecules. There will be the same shared electrons. So the net force will be also equal to 0 and dipole will be also equal to 0. So this is also a non-polar. So we can see here that all homomolecules are the non-polar, right? After that, if we talk about the heteromolecule, here there will be the different atoms, right? Different atoms. For example, H and F, hydrogen and fluorine, these both are different atoms. So this is a less electronegative and this is a high electronegative. Here these both were the same electronegative, like this is also same electronegative and this is same electronegative. Here hydrogen is a less electronegative, fluorine is a more electronegative. So these both are same, we can say different atoms. So here one point is that the different atoms exert different force. So here the electrons will be more towards fluorine because it's having high electronegativity. So the net force will not equal to 0 and dipole will also not equal to 0. So that is called the polar. If the net force and net dipole will not equal to 0, that will be called as a polar molecule. So, for example, another we can say take example like hydrogen bromide. This is a less electronegative and this is a high electronegative. So the electrons will be more towards here. So this is also not, net force will be not equal to 0 and dipole will also not equal to. So this is also polar molecule. We can see that all heteromolecules are the polar in nature. After that, here if we talk about the triatomic molecules, here we have seen the diatomic. Here if we talk about the triatomic molecules, for example BF2 is a triatomic molecule like bromine and F and F, right? This is geometry. So this we can say this is a more electronegative and same this is a more electronegative. So there will be the same force towards here, same force toward here. So the net force will be equal to 0 because these both are putting same force, because these both are the same molecule. So the net force will be equal to 0 and dipole will also equal to 0. So we can say this is a non-polar molecule. This is a non-polar molecule. Now if we talk about the CO2, like here you can see here these both are this is a high electronegative and this is also high electronegative. These both are putting same force. So this is also a non-polar molecule because net force is equal to 0 and dipole will be also equal to 0. Now if here we will talk about S O2 S. These are the two lone pairs of the sulfur. Here one point that the lone pair of electron exert higher force. Lone pair of electron exert higher force. Here you can see that here oxygen is putting force, for example, of 10 Newton, and this is the same 10 Newton. So, and the lone pair will put the 50 Newton force, because as I mentioned here, lone pair of electron exert higher force. So this lone pair will exert higher force. So the net force will not equal to 0, because from here there's a maximum force, and from here this is a lower force. So the net force will not equal to 0. Here we are talking about the triatomic molecules. So the dipole will also not equal to 0. So this is a polar, we can say polar molecule, sorry. After that, if we talk about the polar atomic molecules, polyatomic, which means from we can say that more than two atoms. So there, for example, BF3. Poly means many, right? So BF3. Here you can see that, for example, this is putting force of the 10 Newton. Here this is also fluorine, this will also put 10 Newton, and this will also put 10 Newton. So you are putting same force, so this will be called as a non-polar molecule. This will be called as a non-polar molecule. We can say that all polyatomic molecules are non-polar. Now here, if we talk about another example like H2O, here here oxygen, these are the two lone pairs of the oxygen. As before I mentioned that the lone pair of electron will exert higher force, so this will exert higher force than these two. For example, this is exert 100 Newton force, and these are exerting 50 Newton force. So this will be, net force will not equal to 0, and dipole will also not equal to 0. This will be called as a polar molecule. So this was a dipole movement.